Welcome to this particular module. In the last module what we have seen lithography, and in particular front to back lithography. I told you that it's very important to understand the backside alignment, because if you want to create a diaphragm and the diaphragm should be just below the pressure sensor, then the backside lithography is extremely important. So if you before we go in detail about how it will be useful, we will just quickly look at two videos which is about what is a clean room and class type of clean room and the clean room protocol. As you have also seen, or you may be looking at, depending on our video number, that there are certain protocols that you need to follow when you are to use the clean room facility. Okay, so this will also give you a overview of what exactly you need to, what kind of protocols are there, and how can you gown yourself before you enter the clean room, what you should do and what you should not do when you work inside the clean room, and of course it will also show you the types of clean room. Then we will take very important example, which is a piezoresistive micro cantilever. All right, and in that we will see the importance of your front to back lithography system. So that is a plan. So let me show you the first video. Actually there are two consecutive videos. So first let me play the video. now let me play the second video as well. If you see the screen.
Welcome to Keeping It Clean, How to Properly Use Cleanrooms, provided by NASA Langley Research Center. Cleanrooms are one of the most valuable tools in limiting contamination of sensitive hardware, such as optics, science instruments, and spacecraft. In this video, you'll learn about cleanrooms, how to enter and exit a cleanroom properly, and correct procedures for operating in a cleanroom to ensure minimal contamination. Introduction to cleanrooms. What is a cleanroom? A cleanroom is a room in which the quantity and size of airborne particles are controlled in order to limit contamination. A cleanroom is also constructed and operated in a manner to control the introduction, generation, and retention of contaminants inside the space. Filtered air flows into the room through high-efficiency particulate air, or HEPA filters. Cleanrooms are classified based on the amount of allowed airborne particles in the room at any given time. The fewer particles allowed, the more precautions that must be taken in order to prevent contamination. There are two different types of cleanrooms. Hard-wall cleanrooms have sturdily constructed, rigid walls. Soft-wall cleanrooms have flexible walls, such as plastic sheets or strips. Hard-wall cleanrooms are typically cleaner than soft-wall, but the processes to avoid contamination are similar in both. Cleanrooms can also be classified by the direction of the airflow. Some cleanrooms have horizontal airflow, in which the filtered air enters at one wall and exits through an opposite wall. Vertical flow cleanrooms provide filtered air from the ceiling, and the air flows downwards towards the floor. Cleanrooms are classified under the ISO standard 14644. The classifications are based upon the amount and size of airborne particles in a cleanroom at any given time. The ISO standard covers 9 classes of cleanrooms, with Class 1 being the cleanest and Class 9 being the least clean. This video primarily covers ISO Class 7 and ISO Class 5 cleanrooms, as these are some of the most common classes of cleanrooms used. ISO 5 cleanrooms are much cleaner than ISO 7 cleanrooms, and hence, more precautions must be taken to limit contamination. Preparing for work in the cleanroom. A cleanroom is not an office or a general lab area. Certain items that are perfectly fine in other areas are prohibited in cleanrooms. We have to properly prepare before gowning up and entering the clean area. First, remove any cardboard, paper, or other fibrous outer packaging from items. Paper and cardboard excessively shed particles, and fibers are prohibited in cleanrooms. Only cleanroom notebooks and cleanroom paper may be used in the cleanroom. If regular paper must be used, it should be sealed in plastic sheet protectors or plastic bags. Only ballpoint pens without caps should be used in the cleanroom. Graphite pencils create particles. Next, dispose of any prohibited items, such as paper, trash, etc. Food and drink are also prohibited in cleanrooms. If you don't know whether or not an item is prohibited, consult the contamination control engineer or the manager in charge of your cleanroom. Next, wipe down the outer surfaces of any tools and hardware that you plan on bringing into the cleanroom. This will reduce the amount of particles you introduce to the room. If you are carrying the items in a container, such as a tote, the outer surfaces of the tote must also be wiped down. Use the wipes and solvents provided for your cleanroom area. Wipes may be pre-moistened, or dry wipes with solvents such as isopropyl alcohol may be used. Once a wipe becomes visibly dirty, discard it in the required container and use a new wipe. If shoe cleaners are provided, then use them as demonstrated. Put booties on your feet to prevent tracking in particles. As you enter the cleanroom, take care to step on the adhesive sticky mat, which further prevents particulate contamination. If the adhesive sticky mat is dirty, remove the dirty layer to expose a clean layer before entering the room. Cleanroom gowning, ISO Class 7 or 8. We are now ready to gown up for the cleanroom. First, we will go over the gowning typically used for an ISO Class 7 or 8 cleanroom environment. However, your specific environment may require more stringent controls. Always check with your contamination control engineer or manager. After entering the gowning room, cleanroom users should always gown up in a top-down manner, starting at the head. First, place the bouffant cap over your hair and ears. Make sure the cap covers all of your hair. People with long hair should tie their hair back before putting on a bouffant cap. Next, put on a face mask, completely covering your nose and mouth. This limits particles being introduced to the environment or hardware from our breathing. Next, obtain a smock, which will usually be provided in a clean sealed bag. Cut open the bag with scissors and throw the bag in the trash. Unzip the smock and put the smock on one sleeve at a time, taking care to make sure the smock does not touch the ground or other surfaces. Zip the smock all the way up and secure any snaps at the neck. Be sure to choose a smock size that fits comfortably, not too big and not too small. Finally, obtain clean gloves. The specific type of glove approved for your area depends on the hardware and operations you will be performing. Always handle gloves by the gauntlet, and do not touch the finger and palm portion of the glove. Pull the gloves on and make sure the gauntlet of the glove covers the wrist of your smock. Some areas require additional control and require taping the glove gauntlet to the smock with approved tape. Again, check with your contamination control engineer or manager for this requirement. Check yourself in the mirror to ensure you are dressed properly for the cleanroom. If entering the cleanroom with someone else, use the buddy system and check each other to make sure you are both properly dressed. You are now prepared to enter the cleanroom. Cleanroom gowning, ISO Class 5 or 6. Gowning for an ISO Class 5 or 6 cleanroom is slightly different than gowning up for an ISO Class 7 or 8 cleanroom. Instead of a smock, a full set of coveralls, or bunny suit, must be worn. However, the same principle as before follows, and the gowning process should go from the top down, starting at the head. First, place the bouffant cap over your hair and ears. Make sure the cap covers all of your hair. People with long hair should tie their hair back before putting on the bouffant cap. Next, put on a face mask, completely covering your nose and mouth. The next steps are different for gowning up for an ISO Class 5 or 6 cleanroom compared to an ISO Class 7 or 8 cleanroom. Obtain a clean hood and open any bagging with scissors. Throw the old bag away. Place the hood over the head, on top of the bouffant cap and face mask. Adjust the cover using the buttons in the back if it does not fit properly. Be sure to choose a hood size that fits comfortably. Obtain a set of cleanroom coveralls, or bunny suit. Gather up the coveralls and sit on the dirty side of the bench. It is absolutely important that the coveralls do not drag on the floor while dressing. Carefully step into one leg of the coveralls and then the other leg. Stand up and put your arms in the sleeves, again making sure the sleeves do not touch the ground. Zip the zipper all the way up and secure any snaps at the neck. Tuck the bottom of the hood into the top of the coveralls. Make sure you have chosen a comfortable size and the coveralls are not too big or small. Choose the correct size cleanroom boots. Boots that are too large can cause a trip hazard. Carefully step into the boot. The disposable bootie will remain on your shoes and will be worn inside the cleanroom boot. The leg of the boot is worn over the coveralls. Secure any snaps and tighten all straps for a proper fit. Then swing one leg over to the clean side and then the next. Then stand up. Follow the same procedure for putting on cleanroom gloves, making sure to handle them by the gauntlet and avoid touching the fingers and palm region. The gauntlet of the glove will cover the cuff of the coveralls. Tape gloves as necessary for the requirements of your area. Finally, check yourself in the mirror and check your buddy if you have one. You are now prepared to enter the cleanroom. Working in the cleanroom. When entering the cleanroom, there might be another adhesive sticky mat in front of the door. Be sure to step on it before entering. When in the cleanroom, practice slow and methodical movements so as to minimize the amount of particles you release in the air by moving. Moving around quickly can introduce nearly 50 times as many particles as moving slowly. Be sure to check your gloves regularly for any rips, tears, or contamination. If your gloves are damaged or contaminated, exit the cleanroom and change out of your gloves in the gowning room. Your skin can introduce large quantities of contamination, so properly covering your hands is essential for protecting the hardware. If you have to sneeze or cough, be sure to do it facing away from the equipment. Do not cough or sneeze onto your gloves. Prohibited actions. While in the cleanroom, a number of behaviors are prohibited as they introduce unnecessary contamination. Smoking is absolutely prohibited in the cleanrooms, as it introduces a vast number of unnecessary particles into a cleanroom. Applying makeup in the cleanroom is also prohibited, as makeup is a huge source of contamination. Touching one's face with gloved hands introduces skin and oil to gloves, which then gets transferred to hardware and other surfaces. Removing gloves, face masks, or any cleanroom garments is prohibited in the cleanroom and should only be removed in the gowning room. And absolutely do not open your smock or coveralls to pull items out of your pockets, such as cell phones. Eating, drinking, and chewing gum or tobacco are not allowed in the cleanroom. Do not enter the cleanroom wearing street clothes. Only proper cleanroom garments may be worn in the cleanroom. Do not wear cleanroom garments outside of the cleanroom and then return to the cleanroom. This is especially true for soft wall cleanrooms. Exiting the cleanroom. When finished in the cleanroom, your next step should be to degown in the gowning room. The degowning process goes in reverse order as the gowning process, from bottom to top. Here is the degowning process for an ISO 7 or 8 cleanroom. Take off your gloves and dispose of them in the proper receptacle. Remove your smock. If you are only leaving the cleanroom for a short period of time, you can hang your smock in the cabinet. If not, place your smock in the hamper so that it may be washed and reused. Remove the face mask and bouffant cap and dispose of them as well. Finally, exit the cleanroom, take off your booties, and throw them away. The process is similar for an ISO class 5 or 6 cleanroom. Once again, take off everything in the reverse order. Remove gloves and place them in the trash. Remove each cleanroom boot. Unzip the coveralls, remove the sleeves from your arms, and sit on the cleanroom bench. Remove the hood. Hoods, coveralls, and boots may be hung up in the cabinet for a short period of time, if you will be returning to the cleanroom later that day. Otherwise, place the garments in the laundry hamper. Remove the bouffant cap and face mask and dispose of them in the trash. Exit the gowning room and throw the booties away. Special topics. Depending on the project and cleanroom, special equipment and procedures may be required. If you are required to wear an electrostatic discharge, or ESD, wrist strap, the ESD strap must be worn on your wrist under both the garment sleeve cuff and the glove gauntlet. If your project requires safety glasses, be sure to put these on over top of your face mask and bouffant cap, and under your head cover. If your cleanroom has an air shower, be sure to use it prior to entering the cleanroom. This shower blows pressurized air over the garments, as a final cleaning method to remove particles before one enters the cleanroom. Only one person at a time may use the air shower. To review, practicing proper cleanroom procedures is integral to maintain a cleanroom environment. It helps ensure the safety and success of a given project. When entering a cleanroom, you should dress up from the top down. While in the cleanroom, be sure to move slowly and deliberately, and check your gloves regularly. When exiting the cleanroom, degown in the reverse order. This concludes Keeping It Clean, how to properly use cleanrooms. Thank you for watching, and for following proper cleanroom procedures to keep our sensitive science instruments and spacecraft clean.
All right. So now, as you have seen in the videos, right, you now have idea of some clean room protocol. Let us talk about a very innovative cancer diagnostic tool. Now, when I talk about cancer, we will talk about tissue related cancer, and when you talk about tissue related cancer, there will be many cancer, starting from breast cancer, oral cancer, cervical cancer, lung cancer, prostate cancer, and many more. Okay. So, cancer that affects the tissue is called tissue related cancer. I am just giving you an easy way of identifying the cancer. Otherwise, technical ways, there is a metastatic cancer, there is a non-metastatic cancer, which is like there is a invasive, non-invasive. We do not worry about that. Right now, what we are looking at is, can we develop a sensor that can diagnose a change in the tissue properties, all right, and what are the changes in the tissue property, and right now how the cancer is diagnosed. Now, why I have taken example of cancer? Because you are developing a sensor, right. So, can you use sensor to diagnose the stage of cancer or type of cancer? So, the current way of identifying the or diagnosing the cancer, it is two ways. One is screening, called screening, and second one is called the diagnosis. Screening is the ASHA worker or the primary care healthcare workers will take the cells from the region which is affected. The cells would be smeared. That means, you take a glass slide, load the cell, take another glass slide and smear it. Then the individual cells, they are stained with HNE. Before you smear it, they are stained with HNE, which is a staining reagent, and then each cell is observed under the microscope by a trained oncopathologist for its morphology. So, the change in the shape of a cell, right, can result in a next step in the cancer diagnosis. If the cells are same, it is okay. If there is double nucleation, cell to cytoplasm ratio, change in the shape of the cell, like I said earlier, right, there are 6 different parameters that people have to understand, and if one of the parameter is identified on the glass slide, which is smeared with cells, then the outcome or the report says atypical. Atypical cells as ATYPICAL, atypical. That is the diagnosis. The diagnosis is not that a patient have cancer, patient have pre-malignant, which is pre-cancer, or patient is normal. No, is for sure it is, it does not look like normal, right. Whether it is benign or whether it is pre-malignant or whether it is malignant, right. Oncopathologists cannot tell based on just a screening report. This study of cells, right, for screening is called cytology. All right. Now, in screening, if we identify that the cells are changing its morphology and the report is saying that it is atypical, this particular subject cells of the subject shows atypical properties, then the subject is asked to go for the next stage, and that stage is called histology. Histology is study of tissues. In histology, the area which is suspected, the tissue is removed from that area and it is sliced with a system called microtome, right, and then further after slicing it with microtome, different biomarkers are applied to study the presence of cancer cells on the tissues, or there are no cancer cells, and vice versa. So, you understand, let us say this is the tissue, slice the tissue, look at the biomarkers and understand whether the set of biomarkers for that particular cancers are present or not. This is how right now the cancer is diagnosed. All right. Now, one is cell study, right, one is cell study, cytology, but if you talk about type of cancer, then the screening method may be different, but the diagnosis more or less when it is tissue related cancer, it is histology and immunohistochemistry, which is also called IHC. All right. Now, we will look at one particular cancer, which is breast cancer, and the reason of talking about or discussing this particular cancer is that it is the second largest cause of cancer related death in women.